Welcome to the Stormsurf video surf forecast for the week starting Sunday, August 30th. First up, a quick look at significant wave heights for the South Pacific Ocean. We see 32-foot seas in the central South Pacific. Part of a gale previously was southeast of New Zealand. Southern hemiswell is in the water. Let's get to the details. First up, a check at jet stream level winds. These winds help support the formation of gales. When those gales do form, help direct their track. What we're looking for is troughs. That is, wind in the southern branch. Here's the northern branch of the jet. Here's the southern branch. Winds pushing to the north. That helps create a clockwise circulation. And in the southern hemisphere, clockwise circulation is associated with low pressure and or storms. Clearly, we have a trough with decent winds, 150-knot winds pushing to the north, helping to support gale formation. We already know there's a gale here because we saw the seas in this region. And let's see how that plays out. Here we go. And that trough is to continue to the east into Monday, and then the trough kind of starts moderating. Winds become a lot weaker, and also notice here, there's a ridge here pushing hard to the south, so that tends to drive storm action south into Antarctica. Anyway, we look back to the west to see if there's another trough, something trying to organize here, but it really doesn't look like much of a trough. No winds associated with it until Friday. Another decent trough, a little bit cut off here though, but let's see what happens here. And it kind of weakens, falls apart, and not a whole lot of support for gale development there. And a big ridge pushes hard to the south here in the southeast Pacific. And there we are a week out. So for the most part, whatever's going to happen has already happened. But there is continued troughiness under New Zealand, which leaves the door open to more gale formation long term. Let's just go right to the wave model chart, see what's been going on. So here we go, significant wave heights for the South Pacific Ocean under New Zealand. We're going back to Wednesday because that's when the trough actually started forming. That created a gale. That gale created 26 to 28-foot seas on Wednesday. And we look at this, this is more of a primer system. Still 36-foot seas, but look at the great circle paths here relative to California. Yeah, they're aimed mainly east of the paths, some energy pushing up, and relative to Hawaii, the situation's even worse. Basically almost perpendicular to the great circle paths up into Hawaii. This is more a, let's say, Peru storm. Look at that, right. See, aimed right up the great circle paths there. But anyway, we roll this out, and this thing got to, 39-foot seas into Thursday, and then petered out. But there was a secondary system that formed behind it, and this is really the one of more interest. 40-foot seas on Thursday night at about 11 p.m. Relative to Northern California, that's on about the 209-degree track. That is shadowed by Tahiti. Relative to Southern California, about the 208, 209-degree track. Same deal, shadowed. Relative to Hawaii, what is that, about the 194-degree track? And no shadowing from Tahiti, but just, again, the perpendicular angle. But that's pretty much typical. Anyway, this thing built up a pretty good size area, 40, 39-foot seas. This is about the peak of it. It was 18Z on Friday. And again, relative to California, that's the... what is that, the 207-degree track? That's still shadowed by Tahiti, but for Southern California, it wasn't, on about the 203-degree track, something like that. So, Southern California will probably get the bulk of this swell, and let's just roll that out. Then it started lifting north a little bit and fading out, and then here's where we are right now. So we'll just roll this out. The point being, there's not a whole lot after this, and don't look to the north. You're not allowed to do that, because we'll get into that in a little bit. Anyway, so secondary system forms here, supposedly. This is Monday. This is like tomorrow, and not a whole lot, little secondary fetch, if you will, but it rolls out and just not a whole lot happening. We're out 162, 174, 180 hours. So basically, that swell, those two systems we saw, basically arrival time for California is in the next weekend time frame, Labor Day weekend. So that's good news. Some southern hemiswell focused mainly, let's say, for Southern California and certainly down into Baja and Central America as well. Let's move on and take a quick look at the northern hemisphere. So we'll do the same thing here. We'll take a look at the jet stream, but we're also looking at the jet stream to examine the possible influence of El Nino on the jet and whether it is helping to enhance the jet. For this time of year, basically the last day, coming in on the last day of August, the jet looks actually pretty decent. Not super decent, not like just raging winter type jet, but yeah, one could say there is some minimal influence from El Nino, but we still have this big ridge here over the western Gulf and pretty much the whole Gulf. Things look pretty well configured here, though, down at 40 north over in the West Pacific. You can also pick out the tropical systems having some impact on the jet. This is up at 30,000 feet. Anyway, let's see how this plays out here. We'll roll this thing. Here we go. The ridge continues, winds build in the west, getting even a upper level trough trying to go there. But see, look at that, there's that big ridge. So that pretty much, any storms coming this way will get diverted up into the Bering Sea. Nice little trough here midweek, working its way down along Canada. That's the second one so far. And look at that, almost pushing into Oregon. Low pressure would be at the surface here. And then finally, by the 90-hour forecast, we're talking Wednesday night, pretty much the whole jet is south of the Aleutians now. That looks pretty good. We'll play this out, and that continues with a decent-looking trough here by Friday over the dateline, kind of pinched off. And sure enough, it does pinch off, and there is tropical activity down. That's sort of driving the jet right there. And then that all passes 180 hours out. Now, we're not doing too bad. Basically, a zonal flow on about 45 degree north running from, let's say North Japan, almost into the U.S. West Coast. We would expect high pressure to still be holding in here and going to hold for probably well into late October, early November. And then we'll see whether El Nino and its influence on the jet punches a hole in that high pressure. That would be pretty typical, though. Let's go down to the surface. Here we are, surface level winds, surface level pressure, 1024 millibar high, holding down the mid-latitudes, low pressure up in the Gulf of Alaska, early season low, 30-knot winds, generating wind swell, not particularly high seas or anything, and we'll get into that in a minute, but good enough for wind swell for California midweek. And we have 3 tropical systems, the tropical swarm around Hawaii, Kilo here, Ignacio here, and Jimena here, all looking pretty solid at this point in time. We're looking for storm activity up here. We don't see any of that, but we'll take the tropics. So here we go. We see Ignacio coming very close to the Hawaiian Islands, but not actually touching them. Sure, giving winds, but mainly good for swell radiating into northeast-facing shores of all the islands. And of course, Jimena off here to the east, and then Kilo just sort of roaming around, not really going anywhere on the dateline. Roll this out. High pressure blocking the path to the north, so they all they're going to just flow right around, something like that. At least that would be the guess. Roll this out. So let's see. Ignacio rolls off past the islands, stalls around up here. Jimena continues its approach, and again, Kilo, this is by Thursday, still just sort of not really going a whole lot of anywhere. Actually, now this guidance says down to the southwest. Anyway, roll this out. So then, gosh, how's this play out? I mean, they don't really do a whole lot. They sit here, at least per this model, for a whole week. If nothing, these two guys are getting bigger. This one gets smaller. And notice high pressure is weakening here in the upper levels. So we have a whole week of just systems sitting here churning. There is some thought that swell will be working its way into California from Jimena, and certainly swell for Hawaii from this system. This guy, unknown. He's just a fish storm right now. Not really. Certainly swell for Japan and the Philippines will probably result. But what we really want to see is these guys go north, get caught by the jet, and go extratropical. Then that super fuels them. They become much bigger and much more powerful and have the capacity to generate significant swell. During the major El Nino of 97, that's exactly what happened. A storm in the West Pacific got caught by the jet, made it to the dateline, supersized 45-foot seas, and produced a swell in the 10-foot at 22-second range in the tail end of September. Never quite seen a swell like that clean, that early in the year, and with that much power. So that's sort of the benchmark for what consists of a supercharged El Nino winter early season swell. We'll see whether any of this does that. The jet doesn't look really strong enough to probably do it at this point in time, but we still have time to go. Let's keep going. So we're actually going back a week. This is what was Super Typhoon Atsani off Japan Sunday a week ago. It did the recurve thing. Didn't really get caught by the jet though, and produced, according to this, in the 40-foot range of seas, maybe a little bit more. A lot of this blackness here is really just, there's so many of these contour lines, they just all turn into a blob because they're so compressed in a tight area. The point being here, Atsani faded out by Wednesday, but swell made it to Hawaii on Thursday evening. A pretty decent sized swell, a couple feet overhead, and swell is now hitting California. Pretty much has peaked, we believe, this morning in the pure swell 3 feet at 18 seconds up in Northern California. Good for, maybe a foot overhead at some better breaks. For August, though, any tropical swell that reaches Hawaii, not tropical, well, tropical induced, but from a northerly direction in the North Pacific this time of year, that's a good sign. That's sort of a teller of maybe what is to come. Anyway, so here we are. We're current 18Z Sunday. Here's our 3 tropical systems. Here's our system up in the Gulf of Alaska. Those seas are pretty much, 14 foot. That's good for 9 or 10 second period wind swell, not a whole lot. And we'll just roll this out. You can see, basically, you're not going to see anything different here than what we saw on the surface level charts. The storm's doing basically new storm here forecast, though 100 hours out. We'll believe that when we see it, and it doesn't really do much anyway. The 3 tropical systems all are kind of in their own orbits, doing their own thing, and yet a week from now, we're not a whole lot different from where we are right now. Very interesting scenario. Steering direction not real good. Not a lot of jet influence down here. All the energy's up here. But still, if you're in Hawaii, certainly swell from 1, 2 systems. Maybe even a little swell for California. And certainly over here in Japan in that area. And just a real quick look at Ignacio. Infrared and visible imagery here. Get a quick view of what the storm looks like, and let's go take a look at the track. And here we are, Ignacio right here, peaking out, 120 knot winds. That's a 138 miles per hour. And here's the track. Notice slow weakening forecast as it passed north of the island. Still, it's not moving particularly fast. Fetch, so counterclockwise circulation, northward fetch, pushing into all the islands. And even back here, that's sort of a northeast fetch. Swell for sure for the islands from this one. And Jimena, also satellite image, clearly defined eye. You get this good, clean kind of eye. Typically shows up when you start getting 90 knot winds or stronger. And here's the track for Jimena. Currently, it's right here. What is that? Better part of about 1,500 nautical miles east-southeast of the Big Island, 125 knot wind, supposed to go up to 135 knots this evening, and then it's pretty much downhill from there, quite a ways away from the island chain, but still swell given the strong winds. It's not particularly huge in aerial coverage, but solid. Swell certainly will result, also because of the relatively slow forward speed. Some swell could make its way back to California, but we're not holding our breath on that one. All right, so let's get into El Nino, the El Nino situation. So we're changing the order of things here a little bit. First, we're going to take a look at winds in the Kelvin wave generation area, basically that area from about 135 east to a little bit over the date line. Okay, here's actual winds. We see westerly winds in the northern part of that area, but for the most part, just rather light winds here. Here's the actual anomalies, and that's what generates Kelvin waves. That is, any slackening of trades in this area will push warm water in this area to the east, to depth, forms a Kelvin wave, a pocket of warm water under the equator, travels the whole way across the Pacific, and then erupts over off the Galapagos and Ecuador, forming a warm pool. And that's exactly what we see here, but we're not going to. So anyway, so we see westerly anomalies, pretty strong westerly anomalies for that matter, north of the equator, light westerly anomalies on the equator. Notice no anomalies over here. So what's been happening all year is we've had strong west winds over in this area, and a little bit at a time, the line of where the west winds start is working its way off to the east. That's typical of a maturing El Nino. What you end up with is basically no precipitation or precipitation anomalies north of Australia, dryness there, and then you get all your precipitation following the western anomalies, and particularly over where the warm water is. And you see here anomalies 1.5, 2.5 degrees on the surface. We'll get more into that in a minute, but right now it's the winds that we're interested in. So here's the Kelvin wave generation area. Actually, it goes off a little bit over more than what we have on this chart, but it gives you a general idea. What we're looking for is trades. That is winds out of the east in this area. That is typical to see like 15-knot trades in this area. Notice we see none of that. If anything, we're seeing northwest winds at 12 knots or so, or even stronger off in here in the 18 to 20 knot range, maybe a little bit less, maybe 16 to 20 knots. That's a total reversal of trades. That's exactly what you want to see in El Nino. We'd like to see it covering more of an area, but the reality is these are all anomalies, westerly anomalies, and then actual west winds. We'll just sort of roll this out and look at the forecast. We continue to see, look at this, westerly winds into, maybe Tuesday or so, and then things just go dead after that. No wind at all, or very, very light winds. Little bit of maybe some more westerly winds here, more in the northern half, and this is a conservative view, this 3 north, 3 south. Some folks would say it should be more up like 5 degrees, but we tend to be conservative and not get our hopes up too much. Anyway, so we roll this out. Literally, we're not seeing any trades at all of any magnitude. Here's a week out. Basically the same thing. So the expectation to be westerly anomalies, if not out and out west winds. That helps transport more warm water to the east, and that's exactly what we want to see for a decently developing El Nino. Here's another way to look at westerly winds. The Kelvin wave generation area is roughly, I don't know, draw a line there to there. And oranges and reds are westerly anomalies. If the pinks and the reds are out and out westerly winds, we're back in time in July. Notice we've had westerly winds, nice westerly wind bursts there and there into August. Then we had a bit of a pause here. This was just the past week or so from what was that, let's say the 18th of August through, notice, so this is up at 850 millibars. We did not get any easterly winds down at the surface, just kind of calm winds, no westerly anomalies. And then come about the 27th or so, we fell back into the westerly anomaly regime. And now here we are, this little pocket, we saw it on the previous chart of actual westerly winds in the 15-knot range, right on the date line, and that is supposed to hold. And this is 150. So about right there, 140 east is the western limit of the Kelvin wave generation area. So for the next week, you can see here, basically westerly winds or anomalies forecast over the entire Kelvin wave generation area, almost to the Galapagos. The Galapagos are right about here. So very good setup for the next week. Let's keep going. Here's the same style chart, but this overlays atmospheric Kelvin wave, equatorial Rossby waves, the MJO, and the low is basically what we call the low-pass filter here is roughly El Nino itself. And looking back in time, you can see here was the last big MJO, major westerly wind burst, generated multiple cyclone systems, Rossby wave interacting, constructively interfering, as they call it, with the El Nino base state, again enhancing westerly winds. Also, here's another instance of that now. And then here we are right here, basically El Nino all by itself generating a westerly wind burst. That's like tomorrow, basically, if not today, and that continues. And then basically this forecast, this goes out 2 weeks and suggests westerly anomalies, good, solid, steady westerly anomalies in the whole of the Kelvin wave generation area. Like here's the line right here, all the way into, what is that, about 140, so well past Hawaii. The point being, more warm water gets pushed to the east to feed our developing El Nino. Let's look a little bit further out. And let's take it one step further. So here's the same style chart, but the time scale is reversed. The past is down here, moving to the present, and then to the future. Oranges and red, again, are westerly anomalies, if not out-and-out westerly winds. Dateline is right here. The short of it, you can look down this chart and see continued westerly winds and perhaps building fairly strong, if not into a full-on westerly wind burst in the November time frame. What's driving this? Well, according to this, we saw these westerly wind bursts were associated with the active phase of the Madden-Julian oscillation. Okay, that is a periodic oscillation that runs basically 3 to 4 weeks on and 3 to 4 weeks off and goes from west to east, crossing the Pacific Ocean. And when it does in the active phase, it tends to support westerly wind production or westerly anomalies. In the inactive phase, it tends to suppress it. So currently right now, we are in what one could call kind of an inactive state. It's neither MJO active or inactive, just sort of dead. According to this model, we're supposed to go into this weak kind of inactive phase in, the month of September, let's say, roughly. But still, the model suggests westerly anomalies. And then, if you want to take a leap of faith even more, by the time you get to the end of September, we're supposed to go into an active MJO period, feeding yet more westerly anomalies, and then another little active here. But what's going on here? There's something else at play. Okay, Rossby waves. And Rossby waves actually do the opposite. They go from east to west over time, but what they also do is they have active and sort of inactive states, if you will. And notice when the active state pushes through right here, how we are here, you get it sort of boosts up westerly anomaly production if you have an El Nino base state. That is, the Rossby wave interacts favorably or positively with the El Nino base state, enhancing westerly winds. El Nino does most of the westerly wind production. So anyway, here's another Rossby wave forecast for, let's say the first week in September on through September, creating more, sort of boosting up westerly winds. And then you get this MJO thing supposedly going on that does yet more. And yet then you get sort of this dual thing supposedly going on with both the active phase and a Rossby wave. We don't really believe any of that, and especially, the better part of 3 months out. Not believable at all, but it's completely realistic to expect increasing westerly wind production as El Nino, and here we go, here's El Nino, the base state of El Nino amplifies, and you can just count the number of condors and see that that's supposed to continue rolling well into November. So the point being, if you have westerly anomalies or westerly winds in this region, that pushes warm water to the east. That is the hallmark of El Nino. That creates Kelvin waves, that is. Kelvin waves, when they erupt along the Galapagos, warm the ocean's surface. Okay, and we're not even getting into that discussion yet. Right here, we're just talking about production of Kelvin waves. And then if you have Kelvin waves, they interact with the jet stream. They fuel the jet stream, and the jet stream, especially in winter months, fuels storm production in the Dateline and Gulf of Alaska region, and that is why El Nino is good for producing surf and also rain and weather in the California area. Let's continue. So, we talked about westerly winds, that westerly winds create Kelvin waves. Kelvin waves are pockets of warm water that travel under the ocean's surface on the equator from west to east. Let's go see what's going on. And please note, we had a significant, large westerly wind burst that went the whole way from late June all through July, and it's pretty much continued into at least mid-August, kind of backed off for a week there, and now westerly winds are starting again. But the point is, those very strong westerly winds in the June-July timeframe have pushed lots of warm water to the east in the form of a massive Kelvin wave that is poised to erupt in the Galapagos right now. Currently, here is the absolute water temperatures. You can see there's kind of a wall here. You just follow the ISO bars, if you will, isotherm lines here. But a large pocket of subsurface warm water here, 30 degrees, very warm. This has been building consistently for weeks now. But it is not so much the absolute temperatures, it is the anomalies, differences in normal for this time of year. West Pacific over here, East Pacific here, 7-degree anomalies. This is a large and strong Kelvin wave, and if you look at this, it goes from better part of basically south of Hawaii the whole way to Ecuador. The last little part here is blocked out. The array is down. You can see the buoy lines here with the sensors on them, but you can see very much warm water poised subsurface. This is a historically large Kelvin wave. You do not see this very often, so burn that into your memory, because it'll probably be another 15 years till you see one of these again. Here's another view, same thing, August 26th. You can see that is 6-degree, at least, anomalies here. So this image, this is interesting. Notice the little pocket of cool water here. This wasn't here in the last image 5 days ago. Now it showed up again. But there is water moving, very warm water moving to the surface. So this is at, oh, these are in 20, so this is about 85 here. So Ecuador is right about here. The Galapagos are right about here, and we've been noticed pockets of warm water showing up at the surface, and we'll get into that in a minute, around the Galapagos, but maybe not quite so strong along Ecuador. So what happens is you get this upwelling, downwelling sort of pattern when you get multiple Kelvin waves in a row. This is the upwelling phase, cooler water between Kelvin waves, but the point is this Kelvin wave appears to just sort of almost be bypassing that and starting to push warm water up just a little bit west of the Galapagos and in the area of the Galapagos. Also notice here, warm water still falling to depth. So we had westerly winds here. They push warm water to depth, and then you get this sort of pocket, if you will, of warmer than normal water that works its way east and then bubbles up, if you will, along the Galapagos. So yet more evidence of a massive Kelvin wave set to erupt. Here's a way to historically look at things. September, October last year, 1 Kelvin wave. This is the West Pacific. This is the East Pacific. Ecuador is right here. 1 tiny Kelvin wave. This is the false start El Nino of last year. Another Kelvin wave. It's going time down this chart. And then upwelling Kelvin wave phase. Notice cool water. And then we hit January, February this year. Westerly anomalies started in earnest, building 1 Kelvin wave, very strong one too. This one that erupted in the April time frame. Another one right behind it. Notice no upwelling phase at all. And now here's the third one, and you can just see by the water temperatures here. And this is total ocean temperature down 300 meters. So the core of it is much warmer than this. But anyway, you can see forming, working its way to the east. Here's the cool pocket that we've been talking about. We're not really too worried about that. So this is the strongest Kelvin wave so far of probably since the last super El Nino. I don't recall seeing one this strong even in the 2009-2010 El Nino. So this is all very good news. Piles of warm water that has already been transported east or is in flight. And yet one more view. This is from satellite. Strip out all ocean heights. Warm water at depth displaces surface water up because warm water expands. And so you can actually, if you strip out all the waves, all the tides, and any kind of other modulating height effect, then you get the actual height anomaly from normal. We see the very large Kelvin wave here, 15-centimeter anomalies covering a large area here. Basically just another nail in the coffin suggesting, or piece of evidence that's suggesting a large Kelvin wave is in flight, working its way into the Galapagos. And notice here, now there was the cool pocket here. There were no anomalies here. Let's say it was either last week or the week before. Then it filled in, and it's continued to fill in, but the most of the heights here, here's the Galapagos. You get 5-centimeter anomalies here, and the 10-centimeter anomalies are out here. So still, most of the warming has a long way to go. We don't expect the peak of the Kelvin wave to really start doing its thing till the end of September, maybe even into early October. And then even after that warm water erupts, it'll take another month to get caught by the trades and make it right into the what they call the Nino 3.4 area, the area they really measure, that's used to measure to determine the strength of an El Nino. And again, the more warm water on the surface in the Nino 3.4 region, the more energy it imparts in the jet stream and blah, 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 helps produce storms and surf. So we've talked about westerly winds, we've talked about Kelvin waves, we've talked about looking at the Kelvin waves, monitoring the massive Kelvin wave getting ready to erupt in this area. What's happening on the surface in terms of surface water temperatures? Well, clearly we see a very solid El Nino signal. That is warmer than normal water. See cool water there, warm water there. If you saw that kind of temperatures off in here, that would be La Nina. Certainly we do not have that. If anything, we have a very good, solid El Nino pattern. We'll get into the details here. The point being, this area here appears to be warming. This area here is quite warm. We do see little pockets, and this is a low-res image. We'll get into the high-res image. But we do see little pockets here of cooler water. That is part of that upwelling phase of the Kelvin wave cycle. But we expect that all to get completely washed out as the warm water subsurface starts erupting and then starts warming this whole area shortly. In fact, this warming here is relatively new. Here's the view from middle of August. You can see, we'll just sort of go back and forth. Looks like there is getting to be more warming, especially out in here. So that, here's the current image. This is mainly warm water that was here from a month ago, working its way off this way from Kelvin wave number 2. Kelvin wave number 3 is poised. But just to put things in perspective, here is the warm water signature from 97. So we're nowhere near 97 in terms of aerial coverage, but you know, in terms of the girth here. But the other thing is, the 97 El Nino at this time, we actually have more warm water off here in the Nino 3.4 region, way off to the edge here. See, look at out in here, whereas in 97, yeah, we got a lot of warm water here at the surface, but not so much out there. So again, every El Nino has its own signature. The 82-83 El Nino, we don't have the charts right here, but basically it was nothing compared to either of these two, and the 82-83 was a super El Nino too. So the thought is that our current El Nino is somewhere between less than the 97 El Nino, but greater than the 82-83 El Nino. And that is a very good place to be, since those were the two strongest El Ninos ever on record. So here's the high-res data from today. Warm water. Notice this is brand new right here. This pocket of 4-degree anomalies right off the coast of northern Peru here, and also warm water 2.5+ degree anomalies all in this region. And again, here's the Galapagos here, and the warm water west of there. Now let's do a little. Here we are back about 4 days ago, and just sort of see things are they getting warmer? Though certainly not getting any cooler. They're evolving. I'm not sure if it's covering any more area, probably a little bit more so. But here we go back to August 17th, when the cool phase of the Kelvin wave cycle, upwelling phase, pretty much was at its peak. So definitely over time, warm water is building back in. Then we continue off to the west. So the Nino 3.4 region, the area that NOAA monitors for really making the true indication of whether El Nino is present or not, it's pretty much 120 off to 170 west. This image is shifted off a little bit to the right, but you generally get the sense that you have 2.25 degree anomalies over the entire core of this area, and I think it's from 5 north to 5 south. So clearly a lot of warm water in this area, much above normal. Here we are back just like 4 days ago. There was a little break here that we noticed, but there were these developing new pockets here that we think were associated with the newly erupting Kelvin wave. And then the current image shows that filling in, and this one pocket here holding, but warm water, again, working its way off. So there doesn't look like there's any cooling getting ready to happen in this area, which is very good news. What we really want to see is that Kelvin wave starting to erupt and start to really make a solid footprint back in the off of Ecuador and the Galapagos. And we're seeing some signs of it, but nothing that's knocking our socks off quite yet. So in the Nino 1.2 region, this is the area, again, Ecuador, Galapagos area, absolute average temperatures. We had our big peak in the July time frame from Kelvin wave number 2 when it erupted. The cool upwelling phase of the Kelvin wave cycle did its thing pretty much August 20th or so. And now here is the slow march back upward. Current value 1.7 degrees, nothing particularly exciting. It was up to 3 degrees in the July time frame. And then temperatures for the Nino 3.4 region, that area off between 120 and 170 that NOAA monitors. So here was the all-time peak. This was up, I forget what it was, about 2.2 degrees a week or so ago. It has settled down a little bit, but still very solid at 1.9 degrees. So let's be clear. Any El Nino, a minimal is 0.5. A medium El Nino is 1. A strong El Nino is 1.5. When you're up in the 2-degree range, you're bordering already on super El Nino strength. So we're in a really good place already. Again, with that giant Kelvin wave poised to erupt. When it does erupt, a month later, that warm water will make it into the Nino 3.4 range, and that's when we'll start seeing these temperatures. We expect to see them spike up considerably higher than this. So how do we measure the impact of these warm waters on the atmosphere? There's several ways to do that, but there's key signs we're looking for. One of them is difference in pressure between Darwin, Australia, and Tahiti, called the Southern Oscillation Index. When that index is negative, notice it was in August very negative, that suggests that El Nino, or at least a pulse of the MJO, the active phase of the MJO, is in play. And in effect, El Nino effectively is a long-lasting, multi-season-long active phase of the MJO, at least in how it impacts the atmosphere. Current data, right now, minus 27, so we're dipping down again. Minus 27, 30-day running average, minus 19. The peak so far over this whole this El Nino run was right here on August 22nd, and now we're approaching those numbers again. And the 90-day running average, even better indicator, the more negative it is, the better, minus 14.71. This is the lowest we've seen in years. We'll just say it that way. I don't have the official record, but clearly a sign that El Nino over the long haul is developing and maturing. When we see this get down to about minus 18, you know you're in serious, serious territory, and we completely expect that to happen come the October-November timeframe as water temperatures warm, as the seasons change. That will only fuel El Nino more. For this early date, I mean, we're at the end of August, and we're already in nearly super El Nino territory. We're doing very well. And yet, here's another way to look at it. Past couple of years, the 30-day Southern Oscillation Index average. In 2013, we were in La Nina, positive numbers. In 2014, we started looking like El Nino. It sort of gave up the ghost and sort of warbled along in the -5 range. But now look where we are. This year has just been, from January, has been a steady march downward, and we're still on that trend, and we're just now moving into the fall season. We expect the numbers to continue to drop. So again, very well positioned as of right now. Another measure of coupling between the atmosphere and the ocean is the ESPI index, currently at plus 1.85. It was up at about 2.5 a couple of weeks ago, has lost some ground. It went down to about a minus 1.65 or 1.7, is now starting to work its way up. What is this index? Well, really what it's about is measuring the difference in precipitation in this area and this area. Remember we talked about, so El Nino, this is effectively the Nino 3.4 region. Because you have warm water here, you get more clouds on top of it. And what also happens is it shifts the Walker circulation, and what you end up with is high pressure over Australia, less precipitation here. So it's the expected view is less precipitation here, more precipitation here. You can build an index of it as this number goes higher. That suggests that the warm water is having more of an impact on the atmosphere and pushing precipitation into this box, which is exactly what we want to see. So again, this suggests we're in very good shape. Currently, we are on track somewhere, again, between the 82, 83 El Nino and the 97, 98 El Nino per the SPI. So the current situation, in a nutshell, is tropical activity in the North Pacific, generating swell, certainly for Hawaii, maybe something for the U.S. West Coast, but there is north swell from what was Typhoon Atsani already in the water, hitting California, and already has hit Hawaii. That is a good early season indicator of El Nino. Southern Hemisphere, storm under New Zealand has produced southern hemiswell, 2 of them actually back-to-back, expected to arrive into the California region for the Labor Day weekend and for Hawaii, all of about 2 days before that. El Nino, doing very well, progressing a little bit at a time. The westerly anomalies continue to blow. Massive Kelvin wave poised to erupt. Surface water temperatures on the equator are very warm and certainly are expected to get much warmer with the arrival of the next Kelvin wave. And all this appears to be coupled with the atmosphere. The debate is, well, how much coupled is it going to be? Well, the expectation is probably a bit more. We'll see. But right now, things are better than they have been in a very, very long time. Prepare for major surf for this winter. Also, the expectation is that will bring precipitation, snow to higher levels of the mountains in Colorado, the Sierra, and Utah range. So make your preparations for surf and snow accordingly. Get yourself in shape. It's only a matter of time before all this starts really coming to fruition. That is, getting actual surf. It's all theoretical right now, but the expectation is it is going to actually happen. So prepare accordingly. So that's it for this week. We'll do this again next week. Same time, same channel. See you then. In the meantime, go get some surf. Have a good time. We'll see you again soon. Thank you. Bye.